Hi, this is lesson 2.2b, using the least common multiple with word problems. So I'll share my screen. Hit present. Okay, like I said, it's 2.2b, using the least common multiple with word problems. The standard is I can apply the least common multiple to solve word problems. Okay, and there's our NS4 again. That is our standard. So I have a little song for you, okay? So here, let me just make this, if I can, press play and make it full screen.
Fun, but sometimes it's confusing with all the acronyms my teacher is using. I get so lost in class. I turn to my friends and laugh. My teacher keeps on talking and I don't understand her. She speaks a different language I don't comprehend. I reckon I should pay attention to what we are learning. The LCM just stands for the least common multiple of the two or more numbers. Open up your books, write what you see. First write the 4 and then the 3. Just keep count and write them all down. Multiples of 4, 8, 12, and 16. Go on more, you get 20. Then 3's 3, 6, 9, and 12. You should see it repeats. Well, the LCM just stands for the least common multiple of the two or more numbers. The LCM just stands for the least common multiple of the two or more numbers. I've been spending way too long talking about multiples. In fact, the LCM is barely even helpful. You may say, what is that? The letters GCF. Again, you need your numbers, but instead you factor them both to see if there's a number they both are made of. And if that number exists, you found the GCF. Well, the GCF just stands for the greatest common factor of the two or more numbers. So please don't, there's no need to sit and wait, 'cause I've got this now. This will sounds great, I'm sure.
on for a moment there. Okay, hopefully you liked that song and that was helpful to you. We are going to move on to our next slide. Okay, we're going to start with a little review. So the review. What is a multiple? You remember from last lesson, a multiple is a number. It's the multiple of a number is the product or the answer when you multiply two numbers together. That is a multiple. For example, 3 times 2 is 6, therefore 6 is a multiple of 3. 3 times 3 is 9, therefore 9 is a multiple of 3. Remember, it's the answer. 3 times 4 is 12, therefore 12 is a multiple of 3. So it's also known as skip counting. We want to find all the multiples of 3. We circle 3, 6, 9, 12, 15, 18, every third number. Review. Some more review. What is the least common multiple? That is the least common multiple of 2 or more numbers. The lowest match answer of 2 or more numbers is the least number other than 0 that is a multiple of all the numbers. So using the least common multiple with word problems. Yes, we will. Ned is training for a biathlon. A biathlon is when you do biking and running. Oh, no, this case he's swimming. Swimming and biking. He will swim every 6th day and bicycle every 8th day. What is the first day that Ned will both swim and bike on the same day? This is a least common multiple word problem. You want to know when something will happen at the same time. So step 1, start by listing the first 5 multiples of each number. What are our 2 numbers that we're going to use from the problem? We're going to use 6 and we're going to use 8. We're trying to find the least common multiple when we get our first match. So list all the multiples of 6. 6 times 1 equals 6. 6 times 2 equals 12. 6 times 3 equals 18. 6 times 4 equals 24. 6 times 5 equals 30. Remember that the multiples of 6 are the answers. 6, 12, 18, 24, 30. Or skip counting, counting by 6s. Multiples of 8. 8 times 1 equals 8. 8 times 2 equals 16. 8 times 3 equals 24. 8 times 4 equals 32. 8 times 5 equals 40. The multiples of 8 are the answers. 8, 16, 24, 32, 40. Skip counting by 8s. Notice how the multiples of 6 represent swim days, the days he will swim. The multiples of 8 represent the bike days, the days he will bike. You want to know when there's going to be a first match. Do you see one? Bring them back, find the first common multiple match. If no match, list more multiples. Put them back there. You see a match? Yes, 24 is the first match between 6 and 8. So that means what in terms of our word problem? What does that mean? Yeah, that means that 24 is the least common multiple and Ned will both swim and bike on the same day on day 24. That's when he's going to both swim and bike on the same day. Ned is training for a biathlon. He will swim every 6th day and bicycle every 8th day. Okay, same question. Different, same word problem, different question. What are the next 2 days that Ned will both swim and bike on the same day? We found the first one, right? It was 24. How are we going to find the next times it's going to happen on both days, on the same day? Well, we found 24. That was the first match. So we just find another match. We keep going. So we have to put some more 6s up there. 6 times 6, 6 times 7, 6 times 8, 6 times 9, 6 times 10, 6 times 11, 6 times 12. We're looking for a match with the answers. Put some more 8s up there as well. 8 times 6, 8 times 7, 8 times 8, 8 times 9, 8 times 10. Did we find a match? We sure did. 48's a match. Are there any others? 72 is a match. So those are the next 2 days. On day 48 and on day 72, he will also swim and bike. On day 48 and day 72, Ned will both bike and swim on the same day. Note that 48 and 72 are common multiples, but they are not the least or the lowest or the smallest common multiple. The smallest one is 24, the first one that we found. Okay, let's look at skip counting method to find the least common multiple. We talked about it a little bit. Let's try it with this problem. After every 9th visit to a restaurant, you receive a free beverage. After every 12th visit, you receive a free appetizer. If you visit the restaurant 100 times, on which visits will you receive a free beverage and a free appetizer? This is a LCM problem. I'm going to put the number chart up there. This is another method you can use. So I have to skip count by 9s, and I have to skip count by 12s. So let's do that. Let's put squares around the free beverage days. The free beverage days are every 9th day. So let's put squares around every 9th day. So there's 9. What's the next one? 18. What's the next one? 27. What's 9 more days from 27? 36. Notice the pattern. After 36, which number will it be? 45. Then which number? 54. 63. What's next? Yes, 72. What's next? 81. What's next after that? 90. And then what? 99. And we could keep going, right, if we had no more numbers. But we're going to stop at 100. Now, let's put circles around the free appetizers days. That's every 12th visit. So let's circle all the 12s. Skip count by 12. What's after the next? What's the next 12? 24. And what? 36, right? 48. What's next? 60. What's next? 72. What's after that? 84 and 96. Okay? Now, when do you have both a square and a circle on the same day? Where do the circles and squares overlap? These are the common multiples. Do you see where they are? Do you see that they are at, let me get my arrow here, get a different color so that we have a different color. So we see them at 36. We see them at 72. Do we see them anywhere else where they overlap? No, we don't, do we? On your 36th and your 72nd visit, you will receive a free appetizer and a free beverage at the same time. So that's another method you can use. Okay, same question, same problem, different question. So after the 9th visit, you get the free beverage. After the 12th visit, you get the free appetizer. At which visit will you first receive a free beverage and a free drink? This is your least common multiple. Bring our chart back. That's what we had on the previous slide. We have the 36 circled and the 72 circled because that's where they overlap. You get a free beverage and a free appetizer on those 2 days at the same time. Which one is the least? Exactly, 36. 36 is the least common multiple. You receive your first free beverage and free appetizer on your 36th visit. Okay, hopefully that method makes sense to you. So let's do that with our normal method. Same question. At which visit will you receive your first free beverage and free appetizer? Step 1, start by listing the first 5 multiples of each number. We're going to list the multiples of 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27, etc. And our answers are our skip counting. Our answers are the numbers we circled on our chart when counting by 9s. First 5 anyways. Okay, and then we do it with the 12s. And the answers, 12 times 1, 12 times 2, 12 times 3, those are the first numbers we circled on our chart. And then we have to find a match, right? Do we see a match? Do you see it? Should be 36, right? Bring it back. There it is. 36 is a match for both 9 and 12. So the 36th day is the first time he gets a free beverage and a free appetizer. So 36 is the least common multiple. You receive a free beverage and appetizer on your 36th visit. Let's do this again. A store is holding a promotion. Every third customer receives a free keychain, and every fourth customer receives a free magnet. Of the first 100 customers, which customers will receive both a free keychain and a free magnet? So if you're the right number customer, you'll get both. Which one does have to be, right? Here's our number chart again. So we're going to put the 3s as squares. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. I'm counting by 3s all the way to 100. 51, 54, 57, 60, 63, 69, and 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96, and 99. That's for every third customer right here. I want to change that color to blue. Every third customer. Now we have to circle every fourth number or the other one. They get the magnet. So circles for the fourth customer. So 4, 8, which one's next? 12, 16, 20, 24, and 28, 32, 36, and 40, 44, and 48, 52, 56, and 60, 64, and 68, 72, 76, and 80, 84, and 88, 92, 96, and 100. Which ones overlap? Do you see the days that overlap? I do, where you have both a square and a circle on the same number. There's one. There's another one. Do you see any others? There's one there. See if you can find them. There's one there. Here's one here. One over here. And there's one more right there. These are the common multiples of 3 and 4. We want to know the least common multiple, right? Not necessarily for this word problem, but if we're finding the least common multiple, we have to find the one that's the lowest. This question, however, is asking us, of the first 100 customers, which customers are going to receive both a free keychain and a magnet? Well, customer number, oh, I missed one. You see the one I missed? Right here, 12. So 12 is the least common multiple. So customer 12, customer 24, customer 36, customer 48, customer 60, customer 72, customer 84, customer 96 will all receive both a keychain and a free magnet. So customers 12, 24, 36, 48, 60, 72, 84, and 96 will all receive both a free keychain and a free magnet. Do you notice how those numbers, 12, 24, 36, 48, 60, 72, 84, and 96 all go up by 12 every time? Why would that be? Why would it go up by 12? Well, if you think about it, what is 3 times 4? Well, 3 times 4 is 12, isn't it? And 12 is the least common multiple. Does that make sense? Hopefully. And I'll clear this. Note the pattern with these common multiples. I already talked about it. Since 3 times 4 is 12, every 12th customer will receive both items. Okay. Okay. Same question, but same word problem. But this is a new question. Which customer will be the first to receive both a keychain and a magnet? We only have to find the first match. Where's the first match? Exactly, it's 12, right? That's the first match. 12 is the least common multiple. The first customer to get both a keychain and a magnet is the 12th customer. Be careful to know what the question is asking you. Does it want all of them up to a certain number, or does it just want the first one, which is the least common multiple? Here is our normal multiplier method. This is the one we were talking about yesterday. Same question, what do we do instead? We list the first 5 multiples, multiples of 3. 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. The answers are the multiples of 3. The products are the multiples of 3 when you skip count by 3s. For the 4s, we do the same thing. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. The multiples of 4 are the products or the answers. And then we find our first match. We'll bring them back. Our first match is 12. 12 is the least common multiple. The first customer to get both a keychain and a magnet is the 12th customer. Both methods work. Pick the one you like. Now it's your turn to give it a try. Okay, welcome back to this chart again. I said I wanted to see this chart again, see if it makes a little more sense the second time we see it. So the difference between the GCF and the LCM. The GCF lists all the factors that multiply together to give you a certain number. The LCM lists all the products when you multiply numbers by consecutive integers. The greatest common factor is used to find what common numbers divides into 2 different numbers. The LCM is used to find what common product 2 given numbers have. That's the key right there. Let me circle that. This is a key statement. This one and this one. Next one, the GCF is looking for a match for the greatest factor that is common to both numbers. The LCM is looking for the least product that is common to both numbers. We use the GCF to find how many sets of 2 things can be made. We'll see that in a minute. We use the LCM to find when 2 unequal events will occur at the same time. We also use the GCF to work backwards with the distributive property, and we do not use the LCM with the distributive property. Okay, good to keep the distinction between the 2. How to know if you should use the LCM or the GCF to answer a word problem? How do you know? Let's try a question and see. Judith baked 30 peanut butter cookies and 48 chocolate chip cookies to package in plastic containers for her friends at school. She wants to divide the cookies into identical packages. I'm going to underline that and get a different color here. Identical packages so that each package has the same number of each kind of cookie. Does this look familiar from a previous lesson, this kind of word problem? If she wants each container to have the, here's the key word, greatest number of cookies possible, How many packages does she need? Am I going to want to find the greatest common factor, or am I going to want to find the least common multiple? What do you think? What do you think I'm going to use to solve this problem? Some keywords were underlined. Yes, greatest is in the problem. You're going to use the GCF to find the answer to this problem. That's what we did in one of our previous lessons, probably like 3 lessons back. Okay, let's look at it again. Paper cups come in packages of 8. Paper plates come in packages of 12. Eduardo wants to purchase the smallest number of paper cups and plates so that he will have exactly 1 plate per cup. How many of each does he have to buy? What do you think? Greatest common factor problem or least common multiple problem? Which one do you think it is? Did you say least common multiple? Yes. You want to find the least common multiple of 8 and 12. Try another one. Boxes that are 14 centimeters tall are stacked next to boxes that are 21 centimeters tall. What is the shortest height at which the 2 stacks will be the height? 2 stacks will be the height, the same height. No, will be the height. Do you need to use the GCF or the LCM? That one's the least common multiple problem. Did you get it? Keyword shortest? Okay, good. Okay, I'm going to give you a word problem and you're going to decide to use the LCM or the GCF. See you back in a moment. Welcome back. We're going to focus on higher order thinking. Find the least common multiple of 6, 8, and 12. 3 numbers this time. How do we do that? Well, we could skip count and use that chart if we wanted and find where all 3 numbers are circled at the same time. I'm going to use the regular method. First 5 multiples of 6 are there, 6, 12, 18, 24, and 30. The first 5 multiples of 8 are there, 8, 16, 24, 32, and 40. And the first 5 multiples of 12 are there, 12, 24, 36, 48, and 60. Do we have a match? But they have to be a match for all 3 numbers. Do you see a multiple that is in all 3? I do. Did you say 24? Then you are correct. 24 is the least common multiple of all 3 numbers, 6, 8, and 12. If this were a word problem with let's say they got a free dessert on every 6th day, they got a free appetizer every 8th day, and a free beverage every 12th day, when would they get a free dessert, appetizer, and beverage all on the same day? Day 24 would be the first time. The LCM of 6, 8, and 12 is 24. Okay, you give a 3-number problem a try. Okay, welcome back. Your homework will be on Google Classroom, and hopefully the least common multiple is getting a little bit easier for you, and you are doing really, really well. We will see you next time. Bye.